Hello everyone, back again with another video. Welcome to Edu Plus Leisure YouTube channel. So today now again I'm continuing the 2024 A-level chemistry MCQ paper discussion from 2000 from the question 21. Okay, let's continue. So 21 is a question from the organic chemistry. Consider the following reaction scheme. So you can see alkyne compound is reacting with H2 palladium barium sulfate quinoline. So this is hydrogenation reaction, but when you put palladium H2 palladium, if you put with barium sulfate quinoline, this will stop with an alkene. Okay, alkyne will convert into alkene and stop. So there should be a double bond carbon. So obviously 1 and 3 can be rejected. Then they are putting HBr in the peroxide medium. When we are adding HBr in the peroxide medium, Br will combine to the less stable carbocation, forming one. Carbocations are forming during this reaction. Hydrogen will bond to the more stable carbocation containing carbon. So that is why that means HBr in the peroxide medium. So H2 palladium barium sulfate quinoline, obviously the option is this. This is the product. Okay, alkene is forming. Now here you can see the fifth option 2Br has come. So that is possible if you put Br2. Okay, not HBr. Therefore this is wrong. Now the answer is either 2 or 4. Now you can see in the second option, Br has joined to a secondary carbocation forming one. Now here this carbon has the hydrogen, no? Then you can see that's a secondary carbocation. So that is more stable, right? So that will happen if HBr is just added without the peroxide medium. But fourth one, you can see Br has joined to the corner carbon where it is forming a primary carbocation. So that is the least stable one. Br should join to the least stable carbocation forming carbon because HBr is added in the peroxide medium. Therefore answer is fourth one. So this change happens only when HBr present in the peroxide medium. If you put HCl in the peroxide medium, no, same Markovnikov rule will be followed. But if you put HBr in the peroxide medium, anti-Markovnikov rule only will be followed in the product formation. Therefore the correct answer for this is fourth one. Now let's see the 22nd question. At a given temperature, reaction 3ClO minus becoming ClO3 minus plus 2Cl minus occurs to the following mechanism. You can see it's a two-step reaction. First ClO minus combine and form ClO2 minus and Cl minus. Then ClO2 minus is begin combining with ClO minus and forming ClO3 minus. Here you can see ClO2 minus is acting as an intermediate. No, it is forming in the slower step and again it's reacting with the fast. So it's like an intermediate. And so through this mechanism only this reaction is taking place. Now you have to write the rate law for this reaction. Now you know when you have two steps, the rate law of this reaction is following the slower step. Okay, slower step only the rate law of this reaction is written. So K is the rate constant. So slower step is this one. So in this you can see you have 2 ClO minus. Therefore rate law is written as rate equals K concentration of ClO minus A equals, since you have 2 to the power 2. So answer is third one. That's a very simple one. Now let's see the 23rd one. Again another organic question. Compound A forms a colored precipitate with 2,4 dinitrophenyl hydrazine. Compound A also forms a precipitate with ammonical silver nitrate. Compound A react with acidified K2Cr to give product B and a green color solution. Compound B does not dissolve in sodium carbonate. Okay, now compound A, it is forming a colored precipitate with 2,4 dinitrophenyl. That means it should have a carbonyl carbon. No, if you have a carbonyl carbon, Brady reagent, this is what we call it, 2,4-DNP will give a colored precipitate. So carbonyl carbon, we can see it's there in all except 2. Therefore I am rejecting 2 because definitely it cannot give. Then compound A is also forming a precipitate with ammonical nitrate. Now it is not forming silver mirror. If it is forming silver mirror, it should have aldehyde group, but it is forming a precipitate. Then it should have what? Acidic hydrogen. You can see in first one no acidic hydrogen. Then a compound A is reacting with acidified K2Cr2O7 to give product B and a green color solution. You can see Cr2O7 has reduced. Then something is able to oxidize. No. Now you know alcohols, they can oxidize. Now you can see third one you have a primary alcohol, it can oxidize. Fifth one you have a primary alcohol that also can oxidize. Fourth one you have a secondary alcohol possible, only tertiary alcohols are not oxidizing. But they are saying now compound B does not dissolve in A equals Na2CO3. Now you know that not dissolving A equals Na2CO3 means it is not reacting with Na2CO3. Okay, that means now it is not reacting with sodium carbonate. Now let's see, when you oxidize primary alcohols, they are converting to carboxylic acid group. So this is converting to carboxylic acid. This also will convert to carboxylic acid group. But you can see fourth one is a secondary alcohol. Now it is oxidizing for a ketone. Now we should know these points. Then, but you know carboxylic acid is reacting with what? Na2CO3. But our compound B, it is not dissolving with Na2CO3. Carboxylic acid has the ability to evolve carbon dioxide in the presence of sodium carbonate. Then it will dissolve, right? So 3 and 5 will dissolve, but here they are saying does not dissolve. So the perfect answer is the fourth one. 24th question. At a given temperature distribution of kinetic energy of molecules of a gas within sealed container is shown in the following diagram. Now here they are saying the gas is removed and the container is released. So gas is removed. So some amount of gas is removed, and again you are sealing the container and it is cool. That means temperature is dropping. So temperature is dropping means the peak should go where? Peak should go backward. Okay, it should shift to the left side. And since some amount of gas is reduced, it should go down. Area under the curve should decrease because area under the curve is giving you the number of molecules. So but here you are removing some gas, so area under the curve will decrease and maximum boil point will shift to left because the temperature is cooled. Temperature is decreased because of cold thing. Now let's see the 25th one. Now here we can see in this question they have given us the cell reaction. Okay, they have given us the cell reaction. So you know cell reaction, this side we write the anodic reaction and this side we write the cathodic reaction. So anode, you know, it is undergoing oxidation. So zinc should obviously undergo oxidation. Then cathode side, it is undergoing reduction. No, then Fe3 plus should reduce. That means zinc should undergo oxidation to zinc 2 plus and Fe3 plus should reduce to Fe2 plus. Based on that our guesses are 1, 2, 3. Okay, based on that we can reject 4 and 5. Now they are asking what? The E naught cell. You know E naught cell is equal to what? E cathode minus E anode. So E cathode is this 0.77. E cathode minus E anode, no. Anode is minus 0.76. Then minus into minus plus, you have to add 0.77 and 0.76. Then 13, 1 balance, 15, 1.53. Answer is first one. Okay, E naught cell is plus 1.53. Cell reaction is zinc is oxidizing to zinc 2 plus, Fe2 plus is reducing to Fe2 plus. So that's also we can take the answer simply. Now let's see the 26th question. Consider the reaction below taking place in a closed region container at a given temperature. Which of the following statement is true for this reaction? High pressure, high temperature. Now you know the reaction is exothermic. That means forward reaction will release energy and increase the temperature. Now when you increase the temperature, equilibrium will shift backward. Okay, equilibrium shifts where? Backward, because the system should try to reduce the temperature. Because forward reaction is exothermic, no, then it should go backward, then only backward reaction is endothermic and you can reduce the temperature. So it gives the highest equilibrium amount of NO gas. Now let's see the pressure effect. High pressure means equilibrium will shift to the low amount of gases to reduce the pressure. Okay, then that is also there in the product side, you can see. So it's overall the equilibrium is shifting backward, so you cannot get highest amount of NO gas. Okay, then according to the first option, you can see now you can get highest amount of NO if the opposites if these conditions are opposite, right? If you have low pressure, low temperature, you can get highest amount of NO. Now see the fourth option, low pressure, low temperature, give highest amount of NO gas. Now from the first option itself I can predict that I can get highest amount of NO if I can make the equilibrium forward. So to make the equilibrium forward, what should I do? I have to lower the temperature. Temperature should be decreased and pressure also should be decreased. So if pressure is decreased, equilibrium move to the side having more gases to increase the pressure. So more gases you have in the product side. Okay, therefore answer is obviously the fourth one. Low pressure, low temperature only will give you highest amount of NO gas. Now let's see the 27th question. The following information is displayed on the label of a bottle which contains concentrated ammonia, 30% ammonia by mass. That means if you take 1 centimeter cube, 30% only you have pure ammonia. Okay, if you take 1 centimeter cube, in that 30% only pure ammonia you have. Density of it is 0.850 gram of centimeter cube. 400 cubic centimeter of this ammonia solution was reacted completely with H2SO for the amount of ammonium sulfate that can be formed. Okay, let's see. Now you have the ammonia, 30% by mass. The density is 0.850 gram per centimeter cube. Okay, per centimeter cube you have 0.850 gram of that. Now 400 cubic centimeter of this ammonia solution was reacted complete. Now ammonia is reacting with what? H2SO4. First we'll write the balanced reaction, will you? Then you will get ammonium sulfate, NH4, SO4, NH4 you will have 2. Okay, ammonium sulfate and water. So only ammonium sulfate is forming. Okay, ammonia plus sulfuric acid, it is ammonium sulfate. Okay, yeah, now it is totally balanced. Okay, 2 ammonia plus H2SO4 is giving 1 ammonium sulfate. So now here it's reacting. Now they are saying 400 cubic centimeter of ammonia you are taking. Now you have to find the amount of ammonium sulfate formed. So here by the stoichiometry you can compare, then you have to find the amount of moles of ammonia. Now first I'll take 1 centimeter cube. Okay, 1 centimeter cube is having how much? 0.850 grams of ammonia solution. No, in that 30% only pure ammonia is there. So 30% of 0.850 gram is the pure ammonia in 1 centimeter cube, but you need for how much? 400 centimeter cube. So this is how you will find the mass of ammonia in 400 cubic centimeters. So if you find the mass of ammonia, you can find the moles of ammonia, right? Now we'll solve it quickly. Then here 1, here 4, then 0.85 into 30 into 4. So you can see 0.85 into 30 times 4 is 102. So 102 grams of ammonia is present in 400 cubic centimeter. Now we'll find the moles of ammonia. 102 divided by the molar mass of ammonia will be nitrogen is 14, hydrogen is 1, 1 times 3, 3, 14 plus 3 is 17. 102 you have to divide by 17. Then you are getting 6. So there are 6 moles of ammonia. 6 moles of ammonia. Now you can see ammonia to ammonium sulfate ratio is 2:1. That means exactly half of ammonium sulfate only should form, that is 3 moles. Now I can find the mass of ammonium sulfate, that is moles into molar mass of ammonium sulfate. Moles of ammonium sulfate is 3. Molar mass, now you have 2 nitrogen, that means 28, 8 hydrogens, 1 sulfur, 4 oxygens is 64. 10, 12, 22, 2 balance, 9, 10, 11, 12, 13. It's like 132. 3 2s are 6, 3 3s are 9, 3 1s are 3. 396 grams of ammonium sulfate will be forming. So this is the way we are solving this sum. Then you can see the answer is 2. 28. What is the major product of the following reaction? Excess PCl5 now they are adding. Now this will be substitute with chlorine. Carboxylic acid also reacting with PCl5, but this group will not react with PCl5 because this is a phenolic group. Okay, so removing this hydrogen and replacing it with chlorine is very difficult. It is clearly explained in the resource book. Therefore, according to that, we can take the answer is 5. 29 is also a very good calculation question. So before 29, I will first complete 30 and come for 29. Okay, because 29 takes a bit of time. So consider equivalent reaction given below. Kc is 50 at temperature 600 degree. Equimolar amounts of H2 and I2 and HI gas were inserted into 2 discs previously allocated closed rigid current room temperature, and you brought the temperature to 600 degree C. Okay, now you brought the temperature to 600 degree C. So therefore you can compare with this Kc because this Kc is for 600 degree C temperature. Now first I will find Qc. Now they are saying equal amount of HI was added, it seems. Okay, equal mole amount. Now we'll say this is X mole. This is also X mole, this is also X mole. Everything X mole they have added. Okay. Then if I write QC expression, so concentration of HI, now concentration I'll take proportional to moles. Okay, X squared over concentration of H2 into concentration of I2. So you can see up and down both are cancelling and QC is equal to 1. So QC is less than Kc. So 1 and 2 you can reject. QC less than Kc. So if QC is less than Kc, what will equilibrium try to do? Equate QC to Kc, no? So if you want to equate QC to Kc, what you have to do is you have to increase QC. So if you want to increase QC, the numerator of QC expression has to be increased. Numerator you have the HI gas concentration. So if you want to increase the HI gas concentration, okay, more HI gas will be produced because QC is less than Kc. Okay, so equilibrium will shift forward. Okay, equilibrium will shift forward. Answer is 5 for that. Now let's solve 29 perfectly. Now 29th question, a wood ash sample X contain calcium carbonate and potassium carbonate in 2:1 ratio. So 1 gram of this sample, now what they are doing is they are adding excess HCl, okay. Excess HCl they are adding, then calcium carbonate and potassium carbonate, both of them will react with HCl and they will form the salt, carbon dioxide and water. The remaining HCl, what they are doing is they are titrating it with NaOH, okay, the remaining HCl. So you have to find the percentage of calcium carbonate in the wood. Okay, first we'll write the reaction value of calcium carbonate and potassium carbonate with HCl. So this is the balanced reaction. Okay, now calcium carbonate to potassium carbonate, they are in the ratio 2:1. No, so if I say okay, if I have 2x mole of calcium carbonate, I am having how much? X mole of calcium carbonate. Okay, because they are in the 2:1 ratio. Now we'll find the total HCl first. Total HCl added is 0.3 and 25 cubic concentration 0.3, 25 cubic centimeter concentration, I mean the volume. So you will get 7.5 into 10 power minus 3 total HCl is added. Okay, but you don't know how many HCl reacted with calcium carbonate, potassium carbonate, but remaining is reacting with NaOH, right? So I'll find the moles of NaOH. NaOH is 0.1 into 15, 0.1 mole per decimeter cube into 15 is the endpoint reading, 15 into 10 power minus 3. Then you will get 1.5 into 10 power minus 3 NaOH. So NaOH is 1.5 into 10 power minus 3 moles. Now you know NaOH and HCl, they are reacting 1:1. Therefore moles of HCl reacted with NaOH is also 1.5 into 10 power minus 3 mole. That means that is the remaining HCl reacted with NaOH. Now you can find the moles of HCl reacted with what? Calcium carbonate and potassium carbonate. That is 7.5 into 10 power minus 3 minus 1.5 into 10 to the power minus 3. Then you will get 6, no? Yes, 6 into 10 power minus 3 moles of HCl has totally reacted with what? Calcium carbonate and potassium carbonate. Now calcium carbonate is 2x mole, no? So you can see calcium carbonate to HCl ratio is 1:2. That means you need 4x of HCl to react with calcium carbonate according to calcium carbonate. Okay, potassium carbonate you can see x mole, then you need 2x mole of HCl to react with potassium carbonate. So you can see 4x plus 2x, 6x of HCl has been reacted with calcium carbonate and potassium carbonate. That 6x is equal to how much? 6 into 10 to the power minus 3. If you divide both by 6, then x is equal to 1 into 10 to the power minus 3 moles. That means 2x is 2 into 10 power minus 3 moles. So that is calcium carbonate, moles, no? Now we'll find the mass of calcium carbonate. Mass is moles into molar mass. Now molar mass of calcium carbonate is 100, okay? So moles is 2 into 10 power minus 3, molar mass is 100. That means 200 into 10 power minus 3 means 0.2 actually. Yes, 0.2 grams. Now mass percentage is how much? Mass of calcium carbonate 0.2 gram over 1 gram total into 100. You can see 20%. Answer is 20% is perfectly coming, but here the molar mass details were not given. Therefore, this question was given all marks for the year of 2024. But the answer is there, 20%, third answer. So completely I have discussed the next 10 questions also. So wait for the next videos. Thank you so much for watching.